Okay, so I'm going to work a few more problems from exam one. Um, this was one of the questions where you had this particular filling that consisted of a gold alloy. Then the question asked what mass of each element based on the percent by mass up here and the total mass of the filling material. It's a pretty simple problem to do. You have a total mass of 4.25 grams for everything. 92% of it is gold. So all you have to do to see how many grams of gold that is multiply by the decimal 0.92. It'd be 0.920 because it's 3 sig figs. And then same thing for the silver. 4.25 grams times the percentage that silver would be 0.049, so that only has 2 sig figs, and 4.25 grams times the copper 0.031, so also 2 sig figs. So the first, you just multiply 4.25 times 0.920. Use 3 sig figs because those both have 3 sig figs. So there are 3.91 grams of gold. And then 4.25 times 0.049. This time only to 2 sig figs, so 0.21 grams of silver. And 4.25 times 0.031 gives you 0.13 grams of it being copper. We did have to round those numbers a little bit, but you should be able to add them up and get at least very close to the total 4.25 grams, and that actually does come up to be 4.25 if you added those up for your total amount. So that way you get the contribution of mass from each individual element in units of grams. Next you have you're supposed to calculate the radius of an iridium atom. Given the diameter is this many angstroms, and you're supposed to calculate it in micrometers or micrometers, depending on how you say it. I used to say micrometers. But you look at this part here, you're starting out in units of angstrom, so this is really just a conversion problem. Then you're going to divide it by 2 from diameter to get the radius. So there's a good straight line. Here you have a conversion factor where 1 angstrom, represented by the A with a little circle above it, is 1 times 10 to the minus 10 meters, and then 1 micrometer is 1 times 10 to the minus 6 meters. So you get 2.68 times 10 to the minus 4 micrometers, which equals your diameter. Divide by 2. When you do that, right, you'll get 1.34 times 10 to the minus 4 micrometers. So that's what your answer would be. See if we can get another one here. At 25 degrees Celsius, exactly 1 milliliter of mercury has a mass of 13.6 grams. So that's like the density of mercury at that, say that at that temperature. 13.6 grams of mercury in 1 milliliter of mercury. That's its density in grams per milliliter. how many liters of mercury are required to accumulate a mass of 400 kilograms. So 400 dots, so indicating 3 sig figs, kilograms of mercury. Using that density with another nice straight line, you need to convert that to liters ultimately. So you can use this if you go ahead and convert the 1 kilogram of mercury is 1,000 grams of mercury, and that gets that to cancel out. Then 13.6 grams of mercury occupies a volume of 1 milliliter, and then 1,000 milliliters of mercury would be equivalent to a liter of mercury. So get rid of the grams, get rid of the milliliters, then you would be in units of liters. So you'll notice that your thousands, top and bottom, will cancel out. So really you're just dividing the number 400 with 3 sig figs by the number 13.6, so also 3 sig figs. So you round that to 3 sig figs, and you get approximately 29.4 liters of mercury. And that's pretty much how simple that problem is. We'll continue with other questions from the other exams as we go through.